Okay, so we have learned a little bit about what atoms and elements are, which kind of leads us to our next topic, which is the periodic table. So we'll start off by talking about what it is, a short history of it, and then some organization and about how it's organized and the patterns in it, and then how to read it and get some useful information out of it. And we're really just going to scratch the surface. In a more in-depth chemistry class, you could get a lot more, and we'll talk more about this later on in the year. So, what is the periodic table? You've probably seen a picture of it before, and it looks kind of like this. Not all of them have colors. This one's a little bit color-coded to put elements that are similar in the same color, so they are a little bit easier to find, but they're not always like that. Generally, though, what the periodic table is it is a particular way of organizing the 118 or so elements that have been discovered so far. So that's an important point. When they first started making this periodic table, we probably didn't have a lot of this stuff down, especially these ones in gray down here, kind of on this side right here, and a bunch of these ones over here hadn't been discovered yet. And so that also goes to say, there could be more. What we might have to do is we'd actually have to make another row kind of right in between here. These ones are kind of strange. They actually fit in this little spot, and they chop it out just so the periodic table doesn't take up as much space. But anyways, the important thing to know is that it's just a way of organizing all of our elements. And this is by far the most common version that we'll see, but there are a couple others, and so I just figured I'd show you real quick. This one, you can see there's hydrogen, helium, lithium, bromine, beryllium, boron, and it kind of goes around in a spiral like that. If we look on this one, we can find the same elements: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, and so on. And then we go to the next row, and so that's kind of similar to this one. And if we look back at our regular periodic table, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, blah, blah, blah. So they are pretty similar, and they have things in the same order. It's just the shape comes out to be different. And, this is just still another one. We still have the same elements: hydrogen, helium, lithium, beryllium, blah, 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 and so on. And it's just different ways of organizing it or trying to show you or make it easier to see different relationships and different patterns and things. But we're going to focus almost entirely on the main version of the periodic table. So let's talk a little bit about the history of it. So throughout the 1600s, 1700s, and 1800s, scientists were discovering many new elements. And they started to try to think, we got all these elements, maybe they had 30 or 40 different elements, and they thought, we really need to figure out a good way to organize these and see what's going on, because some of the elements were pretty similar to each other, and then some were very different. So you might think about something like, say, silver and gold. They're both metal, right? And they both are shiny and they're valuable. And they're good at conducting electricity and a bunch of other stuff. They are different colors, but overall they're pretty similar compared to, say, oxygen, which is a gas. We can't hold a piece of oxygen in our hand. It's totally different kind of thing. And so they were thinking about how could they organize things and make the most sense of all of this stuff. So they knew that there were some groups and there were some patterns. And so they started trying to lay things out and figure out a way to lay it out in a table. And what they started doing is lay them out in order of increasing mass. So the lowest ones on one side, and then they go up, the next heaviest one, the next heaviest one, the next heaviest one, and so on. And what they noticed when they did that is that a lot of similar elements were often near each other, but there seems to be periods. And what I mean by that is, if you laid them out in order of increasing mass, it'd be like, this one is a little bit shiny, this one's a little bit shinier, this one's a little bit shinier, this one's really shiny, and then it drop down. And this one's a little bit shiny, a little bit shinier, a little bit shinier, a little bit shinier, a little bit shinier, and then it would drop down and not be shiny. And so you get this kind of wave pattern going along. And so they called those periods. But then there were also some things that were kind of weird. It's like, why is this one in this group? Or why does it go, what's up with this pattern? So they're kind of on the right track, but they didn't quite have it figured out yet. Some things seemed like they were one or two spots out of order, even though they had the mass figured out correctly. And part of that was that some elements hadn't been discovered yet. And so they just laid out everything that they knew and like, well, this is the order of increasing mass. And some of them, they just didn't have some of the elements. So there were gaps. And so it made for some weird things. So then this guy, Dmitry Mendeleev, he was a Russian scientist, and he decided to do organize things based on the atomic number, so just the number of protons that each one had. And so that's going to give a pretty similar order to mass number, but it's going to rearrange things a little bit. But what he noticed was that there were still similar periods, but they kind of made more sense now. And he took each period and he made it a new row. So if we were to go back, I got to go back several slides here. If we go back to this one, imagine if I laid out all these. I had like H, and then next to that I had HE, and then next to that I had LI, and next to that I had BE, and next to that I had B, and so on and so on and so on, right? It'd be a really long line. And he said, well, what if I sort of like chop it, and then I like make a new row, and then I chop it, and I make a new row, and I chop it, and I make a new row, and so on and so on. And the way that he chose where to chop that to make a new row is every time he started a new period. So, for example, hydrogen is a gas. It likes to make a +1 cation. Helium is a gas, but it doesn't like to make ions at all. And then we get to lithium, and that likes to make a +1 ion. So he's like, oh, that's a good place to chop. So he'll put that underneath hydrogen because it's kind of similar. And then BE likes to make a +2, so that didn't really fit in. And then, there's a few more here, but then Ne, neon, doesn't like to make ions. So he put that underneath helium. And then Na, it turns out, likes to make a +1. So all of these guys like to make +1 ions. And he noticed that was a pattern. And it turns out that it really fit together well that way because all of these like to make +2 ions. All these don't like to make ions at all. All these like to make -1 and -2 and -3 ions. And so that was kind of the golden ticket there. He sort of figured out that that was going to be the key to making sense of everything. So let's get back to where we were. Make each period a new row. Yeah, and so like we were just saying, a lot of similar elements ended up in vertical groups. But he left some gaps because he was like, well, this one really doesn't fit in the next spot. It fits in the spot after that, and we don't have anything for one spot. And so he ended up just leaving some gaps in his periodic table, which have since been filled in. So it's really pretty cool. He predicted the existence of a lot of elements before they'd been discovered. And that's still pretty much what we use today. It's changed a lot since his original version, but the main idea is basically the same. Okay, so let's talk a little bit about this organization. You see across the top it says group, and then it has a bunch of numbers, and then it says period, and it has a bunch of numbers. And so we can use this as a way to kind of talk about like which groups and periods we're talking about. So I might say period 6 would mean I'd come over here to my 6 and go down, and that would be CR, MO, W, SG. Those are the abbreviations for a bunch of elements. And they're all going to have some similarities. When we talk about periods, I might say period 4. So I go down here to period 4, and that's going to be everything in this row here. And they're not so much that they're similar, but it's like they sort of build on each other. So K is kind of similar to CA, it's kind of similar to SC, is kind of similar to TI, and so on and so forth. And there's no like real big, the biggest gap here is probably somewhere in this area where we start going from solids to gases. But overall, there's it's like a gradual change. Whereas krypton and potassium here, Kr and K are pretty different, but each step in between them was kind of small. So just, again, I'm throwing a lot at you. This is just kind of overview of the periodic table. So the other thing too is that everything on the left-hand side is a metal, and everything on the right-hand side is non-metal. And so like I was saying, it's this area kind of right in here where we have the biggest change in between elements next to each other. But yeah, generally metals on the left, non-metals on the right. Okay, so I'm going to tell you guys about a tool called ptable.com. We'll look at that in a minute. But first of all, it's just going to give you a little picture like this for each element. And so we're going to talk a little bit about what this information is. So this 2,4 here, if we were going to guess what that's talking about, what do you think it would be? Yeah, okay, so of the numbers we've talked about, it could be the atomic number, the mass number, or the charge. This one happens to be the atomic number. So for this element, chromium, which is, by the way, like if you have like chrome on a car or something like that, that is made from chromium. And its atomic number 24, has 24 protons. Next up, we have this Cr. Well, instead of having to write out the word chromium every time, and some of the elements have even longer names than that. So we have symbols, and symbols are always going to be either one capital letter or one capital letter and one lowercase letter. And that's important because that if you look at a string of elements, it might be you might know if that's a C and an O, or CO as one example. So anyways, element symbol is always going to have one letter capital, one letter lowercase. Then we have the element name. That's just the name written out, chromium. I should also say that a lot of times the symbol, kind of like CR, you're probably like, yeah, okay, that's probably chromium, right? Or oxygen is O, it starts with an O. That is not always the case. Some of the names are based off of the name for that element in other languages. Okay, and then down here, this last number is, we call it the atomic mass. And it's similar to the mass number, but it's actually, the atomic mass is an average based on all of the different isotopes of an element. And so you could have a mass number for one atom, but if you have a bunch of different atoms of chromium, or a bunch of different isotopes of chromium, you're going to average that, and that would give you the atomic mass. Okay? These numbers over here on the right are not super important for right now. Those are the electron energy levels, and that's a little bit more advanced than we're going to worry about for now. Okay, so let's look at another one. So what is the atomic number for this element? Okay, yeah, it's right there. It says 36, right? What is the symbol for this element, the element symbol? Okay, yeah, that's the next thing down. That's Kr. And then after that, we have, what's the name of this element? Okay, element name is krypton. And, okay, 83.798. What is that number telling me? That's the atomic mass. And then again, we don't need to worry about those other numbers over there. Okay, so let's take a quick look at ptable.com. So you can click that link and open it up, and you'll see something kind of like this. And we got lots of numbers and letters and things going around, and colors and all kinds of stuff. But what I think is worth noticing, okay, here's our little chromium we were looking at earlier. It's going to show me a bigger version of the box there. So some of them, it gets kind of cramped down here. It gives you a bigger version here. We have our group numbers across the top here. So I could say, okay, group 13, and I want to just look at the ones in group 13, or I could look at different periods. And I think you can click on this and it will give you lots of information. In fact, if you click on any of these, it will bring up the Wikipedia article for that element or that group or that period, or all kinds of other stuff. So this is a really handy tool. And we're going to use that tool to answer a few questions. So let's go back into presentation mode here. I want to know what element has atomic number 12. Okay, so in order to do that, what I would need to do is go back over here to my periodic table, remember atomic number is going to be this little number at the top, or top left. So I have 1, 2, 3, 4, okay, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so Mg, or magnesium, would be atomic number 12. Okay, next question. What is the name of the element with symbol Na? And you know what? Look at that. I made a mistake. I broke my own rule there. That should be an N and a lowercase a. There we go. So there's just a little, just to show you, like it is important to make sure you put capital for the first letter, lowercase for the second letter. And so I want to know, what is the name, the full name of that element with symbol Na? And I'll give you a hint. It's on the left-hand side of the periodic table. Okay, so that should be sodium. That's one of the ones that doesn't really, Na doesn't look like the word sodium. But the reason for that is because it's based on the Latin name for sodium, which is natrium. And so that makes sense. Na, natrium. There we go. Okay, cool. So next question. What is the element symbol for magnesium? And magnesium is pretty close to sodium on there, so hopefully it's not too hard to find. Okay, so it's Mg, that was easy. All right, what element has an atomic mass of 35.5? And you should be looking more on the right-hand side of the periodic table for this one. Okay, good, so that's chlorine, or Cl. And then next up here, it says, what element is in group 11 in period 6? Okay, so just to make sure we understand how to do that, it says group 11 in period 6. So I go over here to group 11, and I go down to period 6. It says Au, which is gold. So that's another one that's based off of the Latin name. It's not G or Go or something like that. Okay, so we made it through all that. Let's try a few more questions here. So which element has 74 protons? So you should be looking for the atomic number for this one. And again, the atomic number is that number at the top. So if I'm looking for 74, it's going to be W, or tungsten. Another one that doesn't have a name that a symbol that really makes sense with the name. But that's just, tungsten is W. Just got to kind of remember that. Okay. If you were able to find that one, what about which element has 46 protons? What about what element is in group 4, period 4? What element is in group 1, period 1? What element has W for its symbol? We just talked about that one. Hopefully you're paying attention. Okay, and a couple more here. So this one is a little more, I want you to just kind of think about it and think about what you already know. So find 3 elements on there that you had heard of before. So you may not have known it was an element, but you've heard of at least 3 of those things before, I promise you. Okay, what about 3 things that you had not heard of before doing this assignment? All right, and so last of all, I just, we kind of flew through this really quick. We could spend months talking about the periodic table. This is just a little brief introduction. I want to know what other questions you have. Does it make sense? Are you confused? How are you feeling about all that?